In this question, we're told the curve C has equation y equals x cubed minus x squared minus 13x plus 18. The point P, whose coordinate is 2, lies on C. Find the equation of the normal to C at P. So we are trying to find the equation of a normal at a point P. The normal is a straight line, so I require a gradient and a point. With regards to the point, I'm only given an x coordinate. So one of the things I'm going to need to do is find a y coordinate. So if we start by saying x equals 2, then y is going to be 2 cubed minus 2 squared minus 13 lots of 2 plus 18. Now if we work through this, we get 8 minus 4. Actually, let's do all the positives. So I get 8 plus 18 is 26. I then get 26 minus 26 and minus 4, which is minus 30. So we get y equals minus 4. And so the coordinate of P is 2 minus 4. Now I've got a point, I need a gradient. This is a curve, so in order to find the gradient of a curve, I need to use differentiation. I need to find dy by dx. So differentiating y, I get 3x squared minus 2x minus 13. And then of course the constant disappears. So I need to know the gradient at the point x equals 2. So dy by dx is 3 lots of 2 squared minus 2 lots of 2 minus 13. So I get 12 minus 4 minus 13. So I get 12 minus 17. Dy by dx is minus 5. So what I've found at this point in time is this is the gradient of a tangent. I need the gradient of a normal, so we can use the property that the gradient of a normal, or gradient of a perpendicular line, is minus 1 over the gradient of the tangent. So what we get for the gradient of normal is mn equals minus 1 over minus 5, so I get 1/5. Okay, so at this point I've got a gradient and I've got a point, and so finally I can find the equation of my line. So using y minus y1 equals mx minus x1, I'm going to substitute in my values. So I get y minus 4 is equal to 1/5 x minus 2. To tidy this up, if I times the whole equation, let's not multiply it by 2, that's not going to make much sense. I want to multiply by the denominator of my fraction. And let's tidy this up just a little bit so it's clear that this is working. Okay, so I'm going to times the equation by 5 so that I get 5y plus 20 equals x minus 2. So I just want to tidy up and get one constant. So I mean we can put everything on the left hand side, I suppose, by subtract, or we can subtract the 20 from both sides. It's up to you how you rearrange it. So this gives us 5y is equal to x minus 22. And that is the equation of our normal. Let's look at part B. Part B says the point Q, whose x coordinate is A, lies on C and is such that the tangent to C at Q is parallel to the line with equation y equals minus 8x plus 7. Find the possible values of A. Now, if the tangent is parallel to y equals minus 8x plus 7, the gradient of the tangent must be equal to the gradient of this line here. And the gradient of that line is minus 8. So you can either differentiate it or you can just look at the coefficient because it's a line. So now what I know is the gradient of our tangent is minus 8 is minus 8. And so I can use this idea because I also know that dy by dx from before is 3x squared minus 2x minus 13. So 3x squared minus 2x minus 13. So to find the possible values of a, so to find possible x values, in other words, what I need to do is I need to put 3x squared minus 2x minus 13 equal to minus 8 and solve to find my x values. So this is now just a quadratic to solve. So I'm going to do that by adding 8 to both sides. So I get 3x squared minus 2x and minus 13 plus 8 will give me minus 5 equal to 0. So now I want to factorise this. 3 times minus 5 will give me minus 15. Factors of minus 15 that will give me minus 2 would be minus 5 times positive 3. So if I rewrite this and splitting that middle term into 3x squared plus 3x minus 5x minus 5 equals 0. I can factorise the first pair of terms, so I get 3x x plus 1. I can factorise the second pair of terms, so taking out minus 5, and I get x plus 1. So it looks like I've done this correctly now because I've got this common factor of x plus 1, which I'm going to take outside of the bracket, and then my second bracket is formed by the coefficients of those brackets, 3x and minus 5, equal to 0. So this gives me the possible values. X equals minus 1, or 3x minus 5 equals 0. If I add 5 and divide by 3, I get that x is equal to 5 over 3. Okay, well let's look back and see how the marks were awarded in this question. First of all, there is a standalone mark for finding b is equal to minus 4. Next, there's a method mark for attempting to differentiate. There is then a method mark for attempting to substitute in x equals 2 into dy by dx. There is an answer mark for getting that dy by dx is in fact equal to minus 5. And there is then a method mark for using the property between the tangent and the normal. Finally, there is an answer mark for the correct substitution of these values into y minus y1 equals mx minus x1. Okay, so let's look at part B. In part B, there's a method mark just for stating that dy by dx is equal to minus 8 and having that realisation. And then there is a method mark for attempting to collect terms and solve this quadratic. And finally, there is an answer mark once you've got both values, x equals minus 1 and x equals 5/3 for the possible values for a. Okay, well I hope my solution made sense and I hope that you understood how to mark it.